Alright guys, so obviously I'm not here today, but we're still going to be doing the same lesson. Let's go through and let's talk about our lab that we did last class. I'm going to have you guys keep this, hold on to this. This is going to act as your notes. So I will not be collecting this. You will keep this as a form of notes. We will be having a quiz next time covering the types of reactions and the predicting product sheet. So we'll be working on that. So I need you to have out your foldable, your predicting product sheet, your reference sheet you got last class, and your balancing reactions practice, the monster one. We'll be finishing with this. So let's go ahead and let's finish the double replacement section of this foldable. So for the double replacement section of the foldable, we have a reaction in which two compounds, and these compounds have to be aqueous. They have to be. So two aqueous compounds react and exchange like parts. These like parts can be elements, or they can be polyatomic ions, etc. It doesn't particularly matter as long as they're the same charge. And this always creates two new compounds. Wow, that's not how you spell that. Two new compounds. But one of these compounds must be a solid. And I'll explain why in a second. But one of them must be a solid. I guess it could be or a gas. That's fine too. This doesn't happen very much. Usually it is a solid, but I guess there are the occasional ones that might make a gas. Sure, I guess, why not? Okay, so I'm going to have compound AB, and compound AB is aqueous. And compound AB is reacting with compound CD. And CD must be aqueous. And those two things are going to react. And when they react, we're going to switch like partners. So A is positive, C is positive. B is negative, and D is negative. We are making ionic compounds at the end. So if we're making ionic compounds at the end, the products have to be a positive and a negative together. So A is going to be buddied up with D, C is going to be buddied up with B. They just switch places. A and C will just switch places. So, but one of our products has to be a solid. I'll go through that in a minute again. A is going to be bonded with D, plus C bonded with B. One must be a solid. One solid. The other one's going to be aqueous. I like to think of this as a happy dance, and maybe just kind of a weird happy dance, but I guess nobody's sad, so there's that. Remember with the single displacement, we ended up with one person sad and alone? Well, this time, you go on a date with your significant other, and your best friend goes on a date with their significant other, and you run into each other at the date, like at Chili's or wherever you all date, I don't know, and then you are starting to eye her boyfriend, and she's starting to eye your boyfriend, and you're like, cool, why not? Let's switch. I mean, that's bizarre, but I guess there's plenty of Hallmark movies made after that, so cool. Let's just move on from there, but at least nobody's sad and alone. How about that? So, the way you're going to check if one is a solid, you're going to be using something called your solubility rules. And your solubility rules are in two places. There is one type of solubility rules here, and the other type is here. They both say the exact same thing, but you will need to use both of them sometimes. So, just a reminder that if something is soluble, it means that it is aqueous, because soluble means dissolved in water. Insoluble means it's not dissolved in water, which would be a solid. So, you're going to check your solubility rules to see if a solid formed. If a solid formed, the reaction happened, and you would use your solubility rules to predict the state of matter of the products. So solubility rules. Helps you figure out the state of matter. That's the whole purpose of them. So let's go ahead and let's just try that really quick. It's easier once we actually get some chemicals around. So let's do lead 2 nitrate. And remember, these have to be aqueous. So lead 2 nitrate is an aqueous compound. And lead 2 nitrate is clear. It has no color to it. And we're going to react lead 2 nitrate with potassium iodide, Ki. I believe potassium iodide is orange. What is potassium iodide? Maybe it's clear too. I think it's clear too. Okay, and then we've got lead is like, I'm not a big fan of nitrate, but that iodine though, I want that iodine though. So lead is going to switch, it's lead with a +2 charge, is going to switch and buddy up with iodine. +2 charge with a -2 charge, we need 2 iodines to make the charges equal to 0. And then we've got potassium, is ion that nitrate. So potassium's +1, nitrate is -1, those guys are going to go together. Now keep in mind, we still need to make sure that one of these products is a solid. Because if one of these products is not a solid, then this reaction didn't actually happen, and we'll talk about why again in a hot second. So let's go ahead and check. Let's start off with these rules here. So we're looking for either ion, lead or iodine. So I'm going to look through here, and I'm looking at this column here. So there is no lead in this column, but there is an iodine. So it says that iodide compounds are always soluble, meaning they're aqueous, except when when iodine is bonded with silver, mercury, or lead. So when iodine is bonded with lead, it becomes insoluble. That means that lead iodide is a solid. Yay! One of the products is a solid, so the reaction did happen. The other way to check that would be by looking at this chart. You're looking for lead with a +2 charge, and you're looking for iodide. And we're just going to cross over and see where they meet. Lead is a solid. Now, do you see all these spots that are blank, or these spots with the dashes? If you try and use this chart and you come up with a dash or a blank spot, then you have to use this one, and you would go by whatever rule this says. So most people use this most of the time and then use this one when they have to. But that is up to you, whichever combo you want to use. That is fine. So lead iodide is a solid. Let's look at potassium nitrate. I'm going to do potassium and nitrate. Potassium nitrate is aqueous. AQ. I could also have used this. It says potassium is always soluble, and it also says that nitrate is always soluble. So it was going to be aqueous no matter what. All right. I believe that this is clear, and that this would be a yellow solid. So you would actually see some cloudy yellowness. So let's test that. I don't have potassium iodide, but I do have potassium chromate, which works about the same way. So let's use potassium dichromate. So I've got, oh God, a clean test tube here, and I've got some lead nitrate. So I'm going to use this lead nitrate, and I'm going to pour some into my little test tube here. I don't need a ton. I've got some lead nitrate there. And then I also have this orange potassium dichromate. So I'm going to use this potassium dichromate. I'm just going to put a little bit in here. And when these guys come together, we get lead dichromate. And the lead dichromate forms this solid yellow color. Now notice there's not like a chunk of solid in here, but it's more cloudy. So that cloudiness does tell us that a solid was formed. It's like a powder. We could isolate it if we wanted to. We could go through and filter it with filter paper because it also has the potassium nitrate in there, which is aqueous. So that's why it's still liquidy. It's from the potassium nitrate. Now, let's talk about what would have happened if these guys were both aqueous. So if I draw, let's do the lead iodide in here just for simplicity's sake. Lead is a +2 charge. And what was it? Lead nitrate? Sure. NO3 is a -1 charge. Remember, these guys are ions in an aqueous solution. When ionic compounds touch water, they dissociate into their ions. So you're really getting a beaker filled with ions. So we've got the lead ion, we've got the nitrate ion, we've got the potassium ion, and we have the chloride ion. Now, if this reaction, if nothing ever forms a solid, then you still just have ions floating around in a beaker, and they didn't reform in any way, shape, or form. So if we never form a solid, then we're staying in this state and nothing changed. That's why if you have two aqueous products, nothing actually really happened on the microscopic level. But in our case, one of them did form a solid. So in our case, instead of just having ions floating around, we get the lead bonded with the chlorine. And we get a bunch of lead chlorides sitting at the bottom, forming their little solid. And then we get the potassium still just floating around in the beaker because it's still dissolved in water. What am I missing? Nitrates. So it's important to remember that idea of dissociation. And now these guys at the bottom are your solids. And these guys are your dissociated aqueous. So remember, if everything is aqueous, they're all dissociated. It's just a glop of ions floating around. We need one to form a solid in order for something new to have actually been formed. So at this point, you now know what all of the types of reactions are. You should be able to predict them. You should be able to use the activity series to tell if a single replacement reaction is going to occur. You should be able to use the solubility rules to see if a double replacement reaction will happen, and to use the solubility rules to determine the state of matter of really anything. And let's go ahead and practice. So, you guys already have the whole first page done of this worksheet. Now I would like you to finish the double displacement reactions, and then you can just finish the rest, and I'll have the answer key available for you guys to check. After you've done with this, you can go through and you can continue practicing your balancing if you need to. And I want you to determine your types of reactions for each one. I will also post the answer key to this online. So today is a finishing types of reactions, double check your balancing, get everything ready. We will have a quiz next class. So make sure you are prepared fully for a quiz next class and that you are prepared for your double replacement lab. I'm going to have you guys take your double replacement lab with you, and your homework is to do the pre-lab for the double replacement lab. And then you also need to finish those worksheets. So you're finishing the predicting products if you didn't finish it already, worksheet. And however much of the balancing monster practice with the types of reactions on the side that you need to do. But these two are the ones that I'm going to be looking for next class.